Hey everyone, welcome to the Calculating Angled Cut Toolpaths tutorial. The purpose of this video is to help you understand the formula that I gave you on the intro page and how we're going to use that to calculate our toolpaths for accurate angled cuts. So starting off with a square corner, we know that as the tool here goes around the corner, the center of the tool has to pass this corner by a certain amount before it can change directions. So that distance that it has to travel past the corner that's what we call delta, or the change in is what delta stands for, right? So the change, or how far the center of the tool has to go past the corner, is what we're trying to figure out. Square corners are nice and easy because we know that center of the tool has to go past the corner by the amount of the radius of the tool. The radius of the tool in this case, 1/2 inch end mill. So the radius of the tool is 1/4 inch, 250. But what happens when that corner is not square? Let's see what it looks like going around this other corner. Now, this part may look familiar, but don't worry, I'm not going to give away all the answers. Definitely going to leave the fun stuff for you. So, as the tool goes past the corner before it can change directions, we can see there, of course, it's obviously not the entire radius of the tool, some portion of that, and that's where our formula comes in. Right? So what is that delta distance? So here's our formula from the intro page. R, which stands for radius of the tool. Tan equals tangent. Tangent, of course, is a trig function. And for a refresher on all the trig terms and how to figure out all the different parts of the triangle, that'll be in the trigonometry refresher. That's another page in this module. So tan is tangent for now. We just need to understand that's a button on our calculator, right, that we're going to use when we're figuring out this formula. And then A is the angle. Okay, so the angle here, in this case, for this part, is 40 degrees, right? So the angle that we're traveling. And so that's the formula. Now, the formula, one thing to keep in mind is you really kind of need to work backwards. You need to make sure that you divide the angle by 2 before you take the tangent. Otherwise, you get the wrong answer. All right, so if we continue this on, we can see as the cutter's coming down, we're going to have to do another calculation for this corner. And so there'll be 2 calculations for each angled cut. But notice that the delta value, it's always going to go into the angled portion of the cut, right? So it's always going to be in there. It's never going to be on this vertical or horizontal. You're never going to shorten that portion of the cut. It's always going to extend past that corner. Even though you're going this direction, it's still going to be up here. Okay, so since I can't give you the answers to this part, obviously, I've created some practice problems that you'll see as assignments later on in this module. So let's take a look at the first one here. And right here's our formula. So delta, and it says delta x, right? So the first one is x, but for this one it'll be the y coordinate. So it's delta x or y. It's either way. So that's why I usually just talk about delta. All right. So for this one we have our cutter is 1/2 inch, and we have our coordinate here, and then we have our coordinate that we need to calculate using our formula, right? So we know that for the y coordinate all along this line, that y coordinate is going to be the same. So the y coordinate is 1.0 plus the radius of the tool. So the y is going to be 1.25. Okay, now the x we have to calculate using our formula. So r tan a over 2. And so our angle is 43 degrees. So we take 43 degrees, divide that by 2, which is 21.5. We take the tangent of that and then multiply it by the radius of the cutter, right? So the cutter is a 1/2 inch end mill, so the radius would be 0.25. So if we go to our calculator, we'll say, clear everything, 43 divided by 2 equals 21.5. And then over here in the trigonometry functions, we go to tangent. So we take the tangent of that, and we get this number. And then we multiply that by the radius of the tool. So times 0.25 equals 0.0984, blah, 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 all these numbers, right? So we usually just want to grab, four places is good for our calculation. So 0.0984, so I'd probably round that to 0.985. All right, so I come back and I say, so my x at the corner is 1.25, and then I'm going to travel past that in the x positive direction by 0.0985, right? Or I could just add that in here, right? So what is it? 1.25. So plus 1.25. And so 1.3485 would be my x coordinate here, right? So I took the coordinate of the corner on the part, and I added the number that I got using our formula to get this 1.3485. So for this one, I'll do the same thing, just using the y coordinate. So y is minus 0.75 here. All right, so I know if this angle is 43 degrees, right? So now I have to use this angle over here. If I imagine a vertical line here to make a triangle, (43°), we know that triangles angles have to add up to 180 degrees, and the right triangle has one angle that's 90. So these two angles have to also add up to 90 to get us to 180. So 90 minus 43 is going to be 47. So I take 47, divide by 2. 47 divided by 2. Oops, that's not right. I must have made a bad click. 47 divided by 2, 23.5. Now take the tangent of that, tangent, get that big long number, and then multiply that by the radius of the tool, times 0.25, and I get 0.1087. So 0.1087 is the distance in the y direction from the corner here to the corner here. Alright, so my x is going to be this 3.15 plus the radius of the tool, which is 0.25. So my x here would be 3.4. My y is going to be, right here it tells us that it's minus 0.75, but I'm going up, I'm going in the positive direction. So that means 0.1087, and then I go put in my minus 0.75 value, minus 0.75 equals. So minus 0.6413 is going to be my y coordinate for that corner. Minus 0.6413. Alright, so that's how the formula works. So use that, do the angle offset practice assignments, and then looking ahead, like on our NIMS part, we're going to deal with corners where they don't actually give us all the information, right? So that's where we have to use the trig, SOHCAHTOA, and that sort of thing to figure out the corners or the angle, depending on what they give or don't give, in order to get the information we need to put it into our formula. Okay, hope you enjoyed the video. Thanks for watching.